Okay, so let's start CVPR 2020 tutorial on image retrieval in the wild. This section is about live coding demo to implement an image search engine from scratch. I am Yusuke Matsui from the University of Tokyo. Okay, so here we will implement an image search engine from scratch. So it's something like that. It's if you upload image via browser, similar image retrieved by a deep features, and it's implemented by a pure Python. And you can try this system by accessing this demo site. So let me try. If you go there, it's like it's web interface. If you select this image, like in this case, just upload the bird images, then send it, then you can find the similar images like this. So let's implement this system. Okay. So variety of open source libraries are available now. So it makes it easy to implement and deploy an image processing system very easily. So I'd like to show you a demo to implement a content-based image search engine. And this system is actually quite simple. So it takes only 24 lines in HTML plus 43 lines in Python without comments. And we use Keras, which is one of the most famous deep learning libraries, and Flask. This is, again, the most popular web server system. And all code are available here. And again, so website, the demo system is here. So you can try it. Okay, so this is a whole system. Right side, this one is a structure of the directory. So we will implement 3 Python files. The first one is feature extractor.py and offline.py and server.py. Then there's static stuff, it's feature and images and uploaded images. And this is index.html. So in the offline step here, we take database images as an input, then run offline.py. So inside this function, this script, so there's a feature extractor. It's by Keras with VCC16 model. By using this, we extract deep features like this. This is image directory, and this is a feature directory. Then in the online phase, we read these features to here. And this is server.py. And inside server.py, so there's a web server Flask here. Then user access the browser, then upload images to this Flask. Then this Flask call feature extractor, it's same to this one. Then extract deep feature. Then this feature is compared with these database features. Then the similar one is returned. So this is the whole system. It's quite easy, right? So, okay, so let's start. Okay. Okay, so this is VS Code. It's nothing, right? Nothing here. So let's start to implement. First of all, we need to make directory static. Then, static make directory feature image uploaded. Okay. So here static directory and feature directory and image directory and uploaded directory. So it's nothing now. Then let's put some test images here. Okay. So let's say just 5 images here to put in image. Okay. So now there are 5 images, something like that. Okay. Then. Okay, let's show that. Then let's see, start to implement offline.py. Okay. So in this offline.py, so we implement here image, import task, NumPy as NumPy. So this offline the purpose of this offline.py is read images and extract deep features. So first of all, let's check. We can read images. Read the image. We just select .jpeg file. Okay, just read a static image here. So let's check it. Soon offline. Okay, we can see the images are here, right? Then feature path equal. We need to create a feature path here. So we just rename it static feature image stem. So just extract the stem and convert NPY. So feature. Okay. So let's. Okay. So given image, this is image path. This one. Then we just replace the base directory and to feature. Then replace .jpeg to NPY. So it's this one. So just renaming. Okay. So the path stuff here. Okay, the next we will create a deep feature. So we need to extract deep feature. Extract a deep feature here. Then maybe save deep feature here. Save that. Okay, here. Then let's implement a deep feature extractor. Okay, then let's create file feature extractor.py here. So feature extractor.py, this is like, okay, so we use a class, very basic class function, TensorFlow class preprocessing. Yeah, then import image. Okay. Then class application.vzz16 import VZ. So we use VZZ16. This is one of the famous model of deep learning preprocessing input. So Keras provides such VZZ16 in the library. So we can just call read it. So import NumPy as NP. Okay. Then okay, class feature extractor. Okay, so this is a structure. We will create a feature extractor class. This class first instantiates itself by reading some model. Then this class has a function extract. This extract function takes an image as an input, then return the deep feature. Okay, so let's implement that. First base model equal VZZ16 weights equal ImageNet. So self model equal model inputs equal base model dot input. Output equal base model get layer dot fc1 dot output. Okay, so here base model we just read VZZ16 model. We can just call function, then from we can use it, and its weight. We use ImageNet pre-trained features. ImageNet pre-trained the weight. By writing these, we can just download the data model from the internet. Then, since this is a recognition model, so but our purpose here is not recognition. We like to use a deep feature. So we just in this line, this means that we just remove the final recognition layer. 1000 class recognition layer, we remove that. Then we can just use final FC1 as an output. So this model is we can use this model as a deep feature extractor. Okay, then let's implement the extract function. Size it first of all, 224, then convert it to RGB. Okay, then image to array. This is just to numpy array. Then numpy expanding x-axis equals 0. This is just WC1. Process input x equals self model and wait, predict x 0. This is 4096 to 4096. Okay, we can return numpy linear algebra. No. Okay, so this is a kind of typical preprocessing for Keras. So we first resize the images and convert it to the NumPy array. Then we add one dimension. This is batch dimension because we need this one for processing. Then this line is just subtracting average pixel value. This is also a very typical way to use deep learning model. Then this is predict. This predict means we pass this image to the model. Then it returns a 4096 vector. Especially this is batch dimension. So this 0 means just we remove batch dimension. So it's just a 4000 dimensional vector. Then we normalize it. Then return it. Okay. So it's a very typical, easy to use code. And actually, all code are from Keras library, Keras documentation. If you see document, you can see the similar file there. So anyway, we can use this feature extractor. Okay, so next thing is let's extract feature. You can use feature extractor here. Feature extractor. So from feature extractor, import feature extractor. Then let's create feature extractor is feature extractor. Okay, feature extractor. Then feature equal feature extractor dot extract image equal image dot open dot image path. Okay, then print type feature of shape. Let's just check it. So here we instantiate on feature extractor. Then let's just use it here. Feature. Just use it for here extract. Just read the images and extract feature and just show the type and its shape. Just debugging. Okay, let's run it. Okay. So this is TensorFlow stuff. Okay, then it seems working. This is path and this is class number and array and this is 4000 dimensionality. So it's fine. Okay, then we can extract features and save it here. And save it. NumPy save feature path. So that's easy, right? So we already know the feature path, we can just save this feature using this path. Okay. Okay, then our 5 features are saved to feature here. Right. Okay, so the offline part is done. So we can run this function, this script, and we can extract feature. So let's, in this tutorial, we have 100 images. So we can just, okay, let's prepare 100 images for offline phase. And then we use these 100 images for search. Okay, so let's move to the next phase. Wait, let's wait a little bit. It's uploading. Okay, so let's run it again. Okay, let's start to process images. So let's wait. By the way, we need, in this tutorial, we just use CPU. We don't use GPU because we don't train anything. So it's fine for CPU. Okay, then let's create next file, server.py. So this is a server. So we start to create a server. Import numpy identities and from fill import image and for feature extractor, which we defined previously. Feature extractor. Then from date time, import date time. Okay, then from Flask, let's use Flask. Flask is the most simplest web server in Python. Request, it's super easy to use. Then template, okay. Then from passive. Okay, add equal Flask. Okay, def index and CVPR. Okay, then okay. Name. No, okay. This is a very basic return. Okay, very basic Flask application. It's saying nothing. If you run it, the server is automatically launched. It does nothing. Okay, let's check it. Python server. Okay. Okay, and the server is launched. So if you open this one, okay. Okay. So if we access this one, so this server here, this function is called, and this function returns just CVPR, so it's returned CVPR. Okay. So this is the simplest server. Then next, let's use an HTML thing. So we needed to create a folder template, and inside templates. Sorry for the thing here. I just use, okay. Okay, so we use HTML here. Then I'm sorry, but its typing takes time. So we just copy HTML. So this index.html, we use this HTML, but it's just 24 lines of a very simple HTML. It's actually Jinja 2 template, so it's template. And here we defined a form. By using this form, we can upload an image, and they are named as query image. Right? This is our output area, so we can fill something here, area. Anyway, so we save index.html. So here we return render template index.html. Okay. Then this server returns a previously defined index.html. Let's check it. Okay. Okay, let's access it. Here. So now we render the HTML file I showed you. Okay, that's good. So what happens if we select file? So we can select something, this one, then upload it. But it doesn't work, of course. So, because, okay, opening HTML is get stuff. So get stuff is here. But using a form is post stuff. So it's a post signal here. But we didn't do anything here post. So nothing happens. Okay. So let's implement post thing. Okay. Method go post get and post. Okay, then if request dot method is post else sorry. Okay, then return image query image is sent. Receive query image. Okay. Okay. Then what happens here? Okay, first, when we access this website, it is a get action. So we inside this index function, we see this one. So it's render template. So it's just render template, right? Then if we send an image, then it's a post action. So what happens here and send it? Okay, so this is a post. So we reach here. Then it return receive the query image, receive the query image. So we can now here, right? Okay, and then now we can process query image stuff. Okay, then next, so since we like to keep, using template, so index.html. Okay, then by this we can even if the search is done, then we can, okay, let's check it. It's the same. It should be same, right? So this is image post here, and after select something, it's still index.html because we show the same thing here. Okay, then let's process query. Okay. So here, let's take image. So this, by writing this, we can access the uploaded query. Okay, query image. Image open. Stream. Pure image. Loaded image path. Load it. Time now. Format. This is just some strange stuff. I'm considering renaming. Okay, then image save. So what happens? We read this query image and save it on our here, upload it. So let's check it. Where's Chrome? Okay, then here, if we upload it, this one, for example, then send it. You can see here, right. So here, the send it image is saved in the local file. Okay. Okay, good. Then let's move to the. So what happened next here? Query path equal uploaded image path. Okay, so when rendering template, we select this path to the HTML. Then we can show back the return, saved images. Let's see it. Select some chibi, for example, then send it. As you can see, so this image is saved here, and then we can select this image as a path here. So we can in this HTML, this is specifying this image path. Okay, good. Then we have all images, all data, so we can just run search inside this program. Okay, next, so read image feature, read image feature. So the feature extractor is feature extractor we define. Then features equal nothing, image path equal nothing. Then for feature path, in path static feature dot blob numpy file features append numpy load feature path. Okay, the image path is append path image feature path dot stem JPEG. Array features. Okay. So this means that we read features images, feature path here .npy. Then we can we rename it as an image path. Then just save it here. And this line is just convert a list of numpy array to numpy array. Okay. So let's read image feature here. Then run search. Run search here. Query equal feature extract image. Since this is already pure image here, so we can simply use the same feature extractor here. Equal comparing no features minus query equal 1. This is L2 distance. L2 distance to the query. The database to the feature, and alias equal numpy arg sort is 30. Okay, the top 30 result. Then scores equal is ID and image path ID. For ID in IDS. Okay. 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 So here we read this is query image. So we extract query feature vector. Then we compute the difference between query and all feature vectors. Then normalize it. So meaning that this is a distances to the this database vectors from the query. Then we arg sort, so we find the closest items to the query, and we select top 30 result. Then just squares format the thing, then return it. Let's check it. What happens if we select something? Send it. It's typo, sorry. Linear algebra. Sorry. Okay. Do that again. Select something and send it. Okay. Then oh, it's something strange. Linear algebra dot norm. Print score. Oh yeah, sorry. It's okay. It's working. Here. Here. This is scores. So here, since we have the same image, so this nearest one is the same image, so this distance is equal 0. And the next one is, this is distance, and this is path to the image, database image. So it's something like that. So now we can get scores. Okay. So the final step is path this to the HTML back. Okay. Then finally, this HTML renders these result. Okay. Okay, so hope it's working. Select image, dark, send it. Okay, so finally it's working. Okay, so since it's dark and since database side has the same image, so this guy is same, the top one, the distance equals 0. And these are similar images, it's essentially dark. And this is not similar to dark, okay? If we select like, what should I do? Like person type of things. If this is a person, so the result are like person, right? So if we select bird, it's bird, right? Okay, so that's done. So in summary, we can use just 100 lines of code, and we use Keras and Flask. It's very easy to implement an image search engine from scratch, like web server stuff. Okay, so thank you for watching.